convert the following Mealy machine into equivalent Moore machine. Now, when we say Mealy machine, we have already seen that the output is associated with transition. And in case of Moore machine, the output is associated with state. So we need to follow some process here. What we will be doing in case of Mealy machine, what happens? The output is generated based on state. It is associated with state. So whenever the machine is moving, their output gets generated, right? While going to the next state, output gets generated. So what we need to look for is all the incoming transitions which are there on any state. What are the output associated with those incoming transitions? That we need to check first. Let's go for Q0. In Q0, we have two transitions which are incoming. One is from Q1 here, another is from Q0 itself. So the output associated with this transition is A. Let's write down A. Similarly, the output associated with this transition which is coming from Q1 is also A. So we can very well say that output associated with Q0 is A on the incoming transitions. Let's go for Q1. In Q1, we again have two transitions. One is coming from Q0, another which is coming from Q1 itself. This Q0 on the input of B generating output on the input of 0 generates output B and coming to Q1. So output associated with this transition is B, whereas Q1 on the input of 1 output getting generated is A, which is again coming to Q1. So we can very well write this that Q0 has only one output associated with the incoming transition, whereas Q1 has two different incoming transitions associated with them. So this is our first step wherein we are looking for what output is associated with individual states on their incoming transitions. Now what we will do in order to represent the output associated with the state itself, we will classify the individual cases based on how many different outputs are associated with them. Say Q0 had just one output associated. So we can say that in our equivalent Moore machine, this Q0 will have output associated with it as single A, whereas here in Q1 we have two output associated. So let's divide this case as Q1A when the output associated is A. Similarly, state Q1B when the output associated with B. Now by looking at this new states, we will redraw, we'll construct our Mealy machine. Okay, so how many states do we have? Q0 with A output, Q1 with A output, Q1 with B output, three cases. Let's see. We are writing Q0, which is nothing but initial state with A output. Okay. Then we have Q1A when the output associated with Q1 is A. We have Q1B when the output associated is with B. Now here we'll have one issue. What? In case of given Mealy machine, when we do not have any input from the user, it will not generate anything. But if we see here, if we consider this Q0 output associated as A as an initial state, what will happen? Even if we don't give any input, it will still generate some output because there is output associated with this Q0. And on even epsilon input, it will generate some output. But that is something which we don't want. So what we will do here, we'll keep this as any other state. Okay. And we'll have a new initial state. Let's represent it as Q0 dash, wherein output associated with nothing. And we'll consider this as our initial state. Okay. Now what will happen if we don't give any input or epsilon is the input, it will not generate any output. Okay. Whereas if we consider this Q0A as an initial state, it will generate A on the given input epsilon. So now let's go for construction. We'll map these all functionalities to our required Moore machine. What does say? Q0 on the input of 0, what we are having, and on the input of 1, what we will have, that we'll see. Our input alphabet contains 0 and 1. Similarly, our output alphabet contains A and B. Let's go for it. Q0 on the input of 0. What is the transition? Q0 on the input of 0, we are generating B and we're going to Q1. That means state Q1 when the output associated is B. So from Q0 on the input of 0, we are moving to Q1 when the output associated is B. Q0 on the input of 1. What? Q0 on the input of 1, we are generating output A and the transition is to Q0. That means we're not talking about itself. Rather, here we are talking about this, wherein output associated is A with Q0. This is what this Q0. This is nothing but just a variation of this Q0. So ultimately, its functionality will remain same. What? On the input of 1, we will have transition to itself, whereas on the input of 0, we will have transition to this Q1B. Now let's move for simulating the state Q1's functionality. Q1, when the input is 0, output generated is A and the transition is to Q0. That means Q0 when the output associated with A on the input of 0. So from Q1, when we have input 0, next state is Q0 and the output generated is A. So Q1, when input is 0, output generated is A and transition to Q1. Since Q1A and Q1B are nothing but the variations of Q1 itself, same will hold true for Q1B also. 0. Similarly, on the input of 1 from Q1, what do we have? On the input of 1 from Q1, we have transition to Q1 itself, but the output generated is A and not B. So Q1, when the input is 1, output generated is A with Q1. So when the input is 1, we will have Q1A. Q1 when the output is A. Same case from here also. So this is the result. We have our equivalent Moore machine to the given Mealy machine, which is performing the same task. What we did, I will repeat. We have identified the output associated with incoming transitions on every state. Step number 1. Step number 2 is we have segregated the states wherein we have more than one output associated with any state. As we had here Q1 having output associated with the incoming transitions as A and B, we segregated it into Q1A and Q1B having output associated as A and B respectively. Then what we did, based on these three, we constructed our required Moore machine. And we have considered one more thing here, that if the initial state available in the original Mealy machine has some output associated with that, in that case, we shifted our initial state to a dummy initial state, and we are beginning our task from that dummy initial state. We are no longer referring to the earlier initial state as the initial state for Mealy machine. Rather, by introducing dummy, we are referring that dummy initial state as a new initial state for our equivalent Moore machine. And earlier initial state will act as any other state belonging to that Moore machine wherein some output is getting generated. So this is the example of conversion of Mealy machine into equivalent Moore machine. If we want to go for construction of a Moore machine, construction of a Mealy machine equivalent to the given Moore machine, what we will do? The task will be very simple in that case. We need to simply shift the output associated with any state onto the transitions which are incoming onto that particular state. That's all. That is the modifications which we need to do if we are converting a Mealy machine into its equivalent Moore machine. What I will do, here we converted our given Mealy machine into equivalent Moore machine. I will find a equivalent Mealy machine to this newly constructed machine. Okay, we'll have same number of states, Q0, Q0 dash, followed by Q1A, followed by Q1B on the input of 0. Look here, what I'm doing, I'm simply writing all transitions as they are. I'm not doing any other thing. 0, 1, 0, 0, 0, 1. Okay. Now what we will do, whatever incoming transitions on any state, we'll keep this as an initial state. Incoming transitions on Q0 are 1, 2, 3, 4. On all those machines, what we will do, whatever output associated with this Q0, that will apply on those incoming transitions. Q0 as output associated as A, we'll say 1A, 1A, A. Okay. This was this 0, A. This is for Q0. Similarly, we'll do for Q1A now. Q1A has two transitions incoming, 1 and 2. So here we'll say A, A. Q1B has incoming transitions as a 1 and 2. So there we'll say output associated is B. That's all. This is equivalent Moore machine to the given to this constructed Mealy machine. Okay. We are converted to Moore here. Then we have converted to Mealy back. So this is the way to convert a given Mealy machine into equivalent Moore machine and a given or available Moore machine into its equivalent Mealy machine.